Welcome. In this video, we're going to explore a classic infinite series example, and that's here. We're given this infinite series, and we need to determine if it converges or diverges. So it never hurts to get a start by writing out the first few terms of a series. So I'll begin by rewriting the definition here. And, well, when I equals 1, I will have 1 over 1 minus 1 over 1 plus 1. This is for I equals 1. And when I equals 2, I have 1 over 2 minus 1 over 2 plus 1. Now, before I continue in this manner, let's see if we can't write these out and then find a pattern so we don't have to write out all this notation here. So this is 1 minus 1 half plus 1 half minus 1 third. The next terms will be, that is for the I equals 3 term, will be plus 1 third minus 1 fourth. Take a moment and verify that you get the same thing. All right, now that you've verified that you do get the same thing, this is for the I equals 3 term, pause your video and write out what you get when I equals 4. So pause your video, please, and work that out. So you should have gotten what I have here, that is 1 fourth minus 1 fifth. And I'm going to scooch these terms all a little closer, so there we go. So again, this happened when I equals 1, I equals 2, I equals 3, and I equals 4. Now, we can clearly see that negative 1 half plus 1 half is 0. We can also clearly see that negative 1 third plus 1 third is also 0. And negative 1 fourth plus 1 fourth is also 0. So now let's ask ourselves, what is left over? What if, say, I just wanted the nth partial sum? I could go ahead and work all this out again, but clearly I'm just going to be left with a 1. And since the second part of every term cancels out with the first part of the next term, I know I'm just going to have this left. So that's minus 1 over n plus 1. So this is equal to the nth partial sum. Okay, now in order to determine whether or not this series converges, and if I haven't used this word yet, I'm going to use it now, this telescoping series converges, I can just find the limit of the nth partial sum as n grows large. So that's the limit as n approaches infinity of 1 minus 1 over n plus 1. Well, clearly this is going to be just 1, since as n grows large, 1 over n plus 1 is going to approach 0. Now, since this limit is equal to 1, I know this series converges. And let's go ahead and write that out as a conclusion. I was out of space, so I had to resize a bit. I hope this video has been helpful.